This is a revision video for P6d Combining logic gates and using logic gates. When you need a switch for a real life situation, you usually need a combination of logic gates to make it work. One example is when you open a car door. The light usually comes on. The light comes on when you open the driver's door, or the passenger door, or when you press the switch. To show this, you need a combination of logic gates. The two gates in this example are both OR gates, so remember, either input can be high. The truth tables for combining logic gates need to be built up in stages. The first stage is to identify the logic gates and decide which are the inputs. You then need to label each of the inputs and the outputs. So here we've got inputs A, B and D. C is the output from this logic gate and E is the output from this logic gate. You can see that the input to this logic gate comes from D and C. So the output of this one influences the output of this one. Second step is to identify all of the original inputs. So here, A, B and D are the original inputs. In the first row, you need to start with all the inputs as low. You can then change the last one, or the last input, to high. Then change this input to high, and then change them both to high. Then you can change input A to high, and that means you've got 4 new rows to cover all the combinations of B and D that you have already. The next step is to work out the outputs. So, we need to work out C before we can do anything else with this logic gate. So we work out C by looking at its inputs, which are A and B. It's an OR gate, so either A or B can be high for a high output. So these two situations are low, and then the rest of them are high, as we have at least one input which is high. Okay, now we've got C, we can start to work out what E is going to be, because C and D are the inputs to E. And again, this is an OR gate. So here we have C and D's low, giving us E low. And then in the rest of the situations we have at least one input which is high, so that means all these ones are high as well. Combinations of logic gates can be made much more complicated. This combination is for a central heating system and needs to be switched on a wall to work. The heating comes on if the override is pressed, if the timer comes on, or if the temperature is too low. The circuit of logic gates describes the system. So here we have got an OR gate with the temperature and the timer feeding into it. We've got an override here feeding into another OR gate, and we've got the wall switch here which goes into an AND gate. So whatever happens in this situation, it means that the wall switch must also be turned on as well for it to work, because in the AND gate both of the inputs must be high. What you can do now is stop the video and try and construct a truth table for this system. Remember the rules. The diagram's already labelled, so what you have to do is construct a table with columns A to G, then identify your original inputs and set them all as low first. Then you need to work out all the other possible combinations for the inputs. Once you've done that, you can start working out C and then E, and then finally G. Input signals for logic gates can be provided by switches, LDRs and thermistors. A fixed resistor is connected in series with the switch, thermistor or LDR as shown in the diagram. The two components can work as a potential divider. By using a thermistor with a fixed resistor, you can generate an input for a logic gate that depends on temperature. As the temperature increases, the resistance of the thermistor drops, so the voltage across the thermistor decreases, and the voltage across the resistor increases. When the temperature goes above a certain level, the the thermistor resistance becomes so small that the voltage across the resistor provides a high enough input for a logic gate. With an LDR, as light levels increase, its resistance decreases, and the voltage across the resistor increases. When the light increases above a certain level, the resistance of the LDR will have dropped sufficiently to provide a voltage across the resistor that is a high input to the logic gate. If you use a variable resistor in place of the fixed resistor, you can change the point at which the resistance of the LDR or thermistor has decreased enough to provide a high input. This means that for a thermistor, you can change the temperature at which you get a high input. For an LDR, you can change the light level. LEDs can be connected to the output of a logic gate, shown in the diagram. When the output is high, the LED will emit light. When the output is low, the LED will not emit any light. LEDs are often used like this to show that something is switched on. When the output of the logic gate is high, there is a voltage across the LED and resistor, so a current will flow through them. The resistor limits the size of the current that can flow through the LED. Without the resistor, the current flowing through the LED would be too high and it will burn out. This diagram shows a relay circuit. Now, the relay circuit is a device that uses a small current flowing through a coil to switch on a current where there is a much bigger current flowing. These are used where there is an output from a logic gate that is used to switch something on. For example, an LDR may be used to switch security lights on when the light level drops below a certain level. The high output from a logic gate causes a current to flow through the coil of wire, producing a magnetic field. The iron switch within the main circuit is attracted towards the coil. This closes the switch and completes the circuit. The circuit's got the security light within it and the light switches on. Relays are very important circuits. We need to use them because the logic gates are low power devices. The main circuit uses a much larger voltage that would damage the logic gate. The relay circuit isolates the logic gate from the mains for power. Similarly, it isolates the low voltage sensor circuit of a thermistor or LED from the main supply. So we are protecting these low power devices from any damage from the main supply or the main circuit. Okay, that brings an end to this revision session on combining logic gates and using logic gates. You can stop the video now and work through these graded questions.